Hello friends, in this video we will be solving GATE 2017 Set B networks questions. So here is the first question in which we have to find out the transfer impedance Z21. First of all, we will convert the above delta into star by star delta transformation. So let's name this resistor as R1, this is R2 and this is R3. So now R1 is 4 into 2 divided by 4 plus 2 plus 2, which is equal to 1 ohms. R2 is equal to 4 into 2 divided by 8 is equal to 1 ohm. R3 is equal to 2 into 2 divided by 8, which is 1 by 2 ohms. So the given circuit gets modified into the circuit which I am drawing now. 1 ohm over here, then this is R2 which is 1 ohm again, this is R3 which is 1 by 2 ohm, and over here the 2 ohm resistor. This is plus minus V1 and the current is I1. Here it is plus minus V2 and the current flowing is I2. From two-port networks, the equation for Z parameters is V2 is equal to Z21 I1 plus Z22 I2. Now if I2 is equal to 0, then Z21 is equal to V2 upon I1. So let I2 be 0. Now by applying KVL in this circuit, we get V2 minus 3I1 is equal to 0. Therefore V2 upon I1 is equal to Z21 is equal to 3 ohms. In this question we have to find out the voltage VAB. Let us assume the voltage over here as V1 and the voltage over here as V2. By KCL at this node, V1 upon 5 plus V1 minus V2 upon 10 plus 6 is equal to 0. Therefore 2V1 plus V1 minus V2 plus 60 is equal to 0. Therefore 3V1 minus V2 is equal to minus 60. Let this be the first equation. Now again by KCL at the second node, V2 upon 10 plus V2 minus 16 upon 10 plus V2 minus V1 upon 10 is equal to 0. Therefore 3V2 minus V1 is equal to 16. Let this be equation number 2. On solving the first equation and the second equation simultaneously, we get V2 is equal to minus 1.5 volts and hence VAB is equal to minus 1.5 volts. In this question we have to find out the energy transferred from the DC source. This is a Wheatstone bridge and the ratio of these two resistors is equal to the ratio of these two resistors, and hence the bridge is balanced and no current flows from here. Now this and this is 10, this and this is also 10, so their parallel equivalent will be 5 ohms. So the circuit modifies to a 10 volt source, 1 farad capacitor and 5 ohm resistor. And let the current flowing through the loop be I. Now by applying KVL 10 minus 1 upon c, which is 1 upon 1 integral of 0 to t I dt minus phi I is equal to 0. On differentiating this equation, we get 0 minus I minus phi di by dt is equal to 0. On simplification, di by dt plus 0.2 I is equal to 0. So this is a differential equation, and its solution is given by I is equal to k e raised to minus 0.2 t, and the value of k can be found out by putting t equal to 0. At t is equal to 0, I will be 10 upon 5, that is 2 amperes, since the capacitor acts as a short circuit. So 2 is equal to k e raised to 0, therefore k is equal to 2, and the current I is equal to 2 e raised to minus 0.2 t. Now the energy supplied by source E is equal to integration of 0 to infinity V into I dt is equal to integration of 0 to infinity 10 into 2 e raised to minus 0.2 t dt is equal to 20 bracket e raised to minus 0.2 t divided by minus 0.2, and the limits is from 0 to infinity, is equal to minus 100 into 0 minus 1 is equal to 100 joules. In this question, we have to find out the value of capacitor C. For maximum power transfer, the load impedance should be equal to the source resistance. So therefore ZL is equal to 0.5 ohms. Now the parallel equivalent of this resistor and capacitor is Zp is equal to R into minus jXc upon R minus jXc. Now the total load ZL is equal to j omega L minus R into jXc upon R minus jXc. Therefore ZL is equal to j omega L minus j Rxc into R plus jXc upon R square plus Xc square. This we get on rationalizing. Now since the load is resistive, the imaginary part must be equal to 0, and hence the real part must be equal to 0.5. Therefore ZL is equal to R Xc square divided by R square plus Xc square is equal to 0.5. Therefore 0.5 R square plus 0.5 Xc square is equal to Rxc square. Therefore 0.5 into 1 is equal to Xc square minus 0.5 Xc square. Therefore 0.5 is equal to 0.5 Xc square. Therefore Xc square is equal to 1, and hence Xc is equal to 1 ohm. Therefore 1 upon omega C is equal to 1 ohm. But we know that omega is equal to 100 from here. Therefore C is equal to 1 upon omega is equal to 1 upon 100, which is equal to 10 millifarads.